Hello guys, welcome on Tesla Adventures. Now in this video, we'll continue further in rectilinear motion, and you can see that we are starting with type 1 of problems, which are problems based on the motion under constant velocity, or it is also called as uniform motion. So some useful formula would be uh, some formula would be used in these kind of questions. So we are discussing those formulae before starting with the questions. So we know that the instantaneous velocity is ds by dt. The average velocity is s2 minus s1 upon time taken. And if velocity is constant, then we know that instantaneous and average velocities is same. Now we also know that if these two are same, then ds by dt would be equal to s2 minus s1 by time. And if acceleration is 0, and obviously when velocity is constant, then acceleration is 0, then it by default means that dv by dt is 0, and the rate of change of velocity is 0, which means that velocity is constant. And obviously then average velocity or average acceleration would also be 0. now these are very simple concepts which we have already discussed in previous video, and now we are starting with type 1 of problem, and this is the first concept illustration problem. See, I have started a new technique of using the numericals to understand the topic, and it is I have named that technique as concept illustration problem. So I would be using concept illustration problem to illustrate the type of questions which would be formed in these types which I am discussing. That in the type 1 we are discussing the problems which are based on constant velocity and uniform motion. So I would be giving you 3 concept illustration problems, and those 3 problems would cover all the types of problems in this section. Now first of all, in this question you can see that a object has to complete a journey from A to B, and it is completing the journey in such a way such that if he has to travel a total distance of s, then this is the midpoint. AC is given as AC is equal to CB. So if it has to travel from A to B a total distance of s, and it is traveling with a speed v1 for this half distance, and with the speed v2 for the remaining half distance, we have to find out the v average. We have to find out the average velocity. Now we are given only with these 2 variables, v1 and v2, and we cannot use any other new variable. So we have to present the answer in terms of these 2 variables only. So first of all, let us see that we know that, let's suppose this is the distance s and s. So v average would be equal to 2s upon time taken. Now time taken to complete this journey is t1, and time taken to complete this journey is t2. So this is 2s by t1 plus t2, and this is 2s by t1. Now we can write t1 as s by v1 and t2 as s by v2. So cancelling this s with s, so it would be 2 v1 v2 by v1 plus v2. So average velocity in this case would be 2 v1 v2 by v1 plus v2. You can also remember this conclusion. Now if in the second problem, if it is given that if that object is taking some t time in reaching from A to B, and C is not the midpoint of AB, in fact C is the midpoint of time taken by the body to reach from A to B, which means that the time taken by the body to reach from A to C is same as the time taken by the body to reach from C to B. So let us suppose that this time is t and this time is t. So obviously it has traveled with a velocity of v1 for this half time, and it has traveled with velocity v2 for the remaining half time. So traveling with different velocities for equal time, therefore it would be traveling different distances. So V average would be equal to the total distance, which is S1 plus S2, upon the total time, which is 2t. Now we can write down S1 as V1 into t and S2 as V2 into t and divided by 2t. Okay, so this would be V1 plus V2 by 2. So you can also say that you can also generalize this result that if the time is being divided in the 3 equal parts, which means that if this is A, B, and this is C and this is D, and it is given that the time taken by the body to move from A to B is same as the time taken by the body to move from B to C, and it is same as the time taken by the body to move from C to D, which means we have divided time in 3 equal parts, and the speed of that body for the first 1/3 time is v1, and for second 1/3 time is v2, and for the remaining 1/3 time it is v3. So v average would be equal to s1 plus s2 plus s3, because these distances would not be same, obviously, because it is traveling with different velocity for same time, and the time would be 3t, or we can also use the time as 3t, or t is the time which is taken by the body to reach from A to B. So let us assume that this time is t. Now again, S1 would be equal to V1 into t, and S2 would be V2 into t, and S3 would be V3 into t, divided by 3t, and therefore V average would be equal to V1 plus V2 plus V3 by 3. So you can generalize this result, and you can say that if the time has been divided in the complete journey has been divided into n equal times, t1, t2, t3, t4, then we can say that the velocity, average velocity would be v1 plus v2 plus v3 plus v4 up to vn by n. Now if what happens if we say that this is the next concept illustration problem. Let us write it now. Now what happens if we say that if the distance is being divided into 3 parts, let us suppose that this is divided into 3 parts like that this is A, this is B, and this is C, this is D. So distance AC is equal to CD is equal to DB. The speed is V1 in this section, and V2 in this section, and V3 in this section. Okay. So let us write down the average velocity. So V average would be equal to, let us suppose that this is S and this is S and this is S. So the total distance would be 3S, and the time taken would be T1 plus T2 plus T3. Now this is 3S by T1. T1 is S by V1, T2 is S by V2, and T3 is S by V3. Now cancelling S with S, this would be 3 V1 V2 V3 upon V1 V2 plus V2 V3 plus V3 V1. This is the average velocity in this case. Okay, now if it happens that in this case you can see that the object has to travel from A to B, and the complete time taken by the object, the complete journey is divided into 4 parts in such a way such that it travels with the speed v1 and v2 for equal time, you can see that time taken by the body from A to C is equal to the time taken by the body from C to D. And it is also given that the distance traveled by the body in this case is same, DE is same as EB. And it is also given that AD is equal to DB, which means that D is the midpoint of line AB. So how to solve this kind of problem? This type of problem you must have seen in the JEE Advanced exam in almost 2002, 2003, 2004. In those years, the JEE was subjective mainly, and this type of problem was being asked in those JEE exams. So this is a simple problem if we use a simple logic, and if we go by a conventional method that we write all the distances and all the times, then it would be quite difficult to solve this problem. So we would use a smart approach, and in that approach I am assuming that the average velocity from A to D is v01, and the average velocity from D to B is v02. Okay, so these are the average velocities which I have assumed in A to D and D to B. Now you can see that AD is equal to DB, which means that the distance is being divided into two parts. So when distance is being divided, then we know that average velocity is 2 v1 v2 upon v1 plus v2. Okay, and now let us find out v01. So for v01, we can say that in this section AD, the time taken by the body to move from A to C is equal to time taken by the body to move from C to D, which means that time is being divided into two parts in this section. So we can say that the average velocity of this section would be v1 plus v2 by 2, which we have already discussed previously. And the average velocity of this section would be, because distance is divided into this section, so we can say that it would be 2 v3 v4 upon v3 plus v4. Now we can substitute this value here. So v average would be 2, v01 is v1 plus v2 by 2, and into v02 is 2 v3 v4 upon v3 plus v4 divided by v01, which is v1 plus v2 by 2 plus 2 v3 v4 by v3 plus v4. You can if you are thinking that this is a quite huge result or quite a lengthy problem, then you are wrong, because when it would be the question in the JEE paper, then the data would be given and we would be writing the data here directly, and we would be finding the numerical values of v01 and v02, which would be easy to put in this case. So don't assume the problem to be lengthier by only watching this conclusion. Okay, so this is the concept illustration problems, and these kind of problem would be there from type 1. And I would be bringing some more problems from type 1, which would be just the practice problems. In this question, you can see that a car is traveling from A to B with a speed of 20 kilometers per hour, and it returns from B to A with a speed of 30 kilometers per hour. We have to find out the average speed of the car in the whole journey. See, you can see that when the car is traveling from A to B, let's suppose this distance is S, okay, and the time taken is t1 in the forward journey, and in the backward journey, reverse journey, the time taken by the car is t2, because speed is different. So average speed, V average, would be equal to total distance is 2s and the time taken is t1 plus t2. So this would be 2s upon t1 would be equal to s upon 20 and t2 will be equal to s upon 30. So this would be 2 into 20 into 30 upon 20 plus 30. So it would be equal to 1200 upon this is 50. So this is 24. So the correct answer would be 24. Now we move in the next question. In this question you can see that a person is traveling on a straight line without changing its direction, and it moves with a speed v1 for half of the distance, and for next half of the distance it moves with the speed v2, then the average speed. We have already discussed this problem, and you can see that the average speed would be, this is 2v1 v2 upon v1 plus v2. So v would be equal to 2 v1 v2 upon v1 plus v2. So the correct answer would be equal to A, and I think this is also the same thing. So this is 2v1 v2 upon v1 plus v2. Okay, so the correct answer is A and C. Now we move on the next question. Now in this question you can see that a body covers first 1/3 part of its journey with velocity 2 and next 1/3 part of the journey with velocity 3 and the rest journey with velocity 6. So in this case you can see that the total distance is being divided into 3 equal parts and the 3 different speeds is given. So we already know that in this case the average speed would be 3 v1 v2 v3 upon v1 plus v1 v2 plus v2 v3 plus v3 v1. So this would be 3 into 2 into 3 into 6 divided by 2 into 3 plus 3 into 6 plus 2 into 6. So you can see that this would be, this is 9 into 2, 18, and this is 18 into 6. So you can see that yes, this is 18 into 6. So this is 108, and here it is 6 plus 18 plus 12. So this is 36. So this is 108 upon 36. So it would be 3 meters per second. So the correct answer is A. Now we move on the next question. In this question you can see that there is a hall which has a dimension of 10 by 10 by 10. This is a cubical hall, and one fly starts from one corner and ends up on the farthest corner. The magnitude of displacement is, obviously we know that the displacement would be the diagonal of the cube, which is root 3a. So its diagonal would be 10 root 3. So the correct answer would be B. Now we move on the next question. In this question you can see that a particle is moving in a straight line. It has traveled half of the distance with velocity v0, and the remaining distance is covered with velocity v1 for half time and with velocity v2 for the other half time. Now we have to find out the average velocity of the particle averaged over the whole time of the motion, and we have to find out the A plus B value. So we know that if it has to travel a total distance of s, then s by 2 has been traveled, or we can say that total distance it has to travel is 2s, let's suppose. Then s distance is traveled by v0, and the remaining s distance is traveled in such a way such that for the half time it has traveled with v2, and in fact for the first half time it has traveled with v1, and for the remaining half time it has traveled with v2. So we know that in this case time is being divided. So let us suppose that v0 dash is the average velocity in this case, and it would be v1 plus v2 by 2. and in the total journey distance has been divided into two parts. Therefore V average would be equal to 2 V naught into V naught dash upon V naught plus V naught dash. So it would be 2 V naught is V naught and V naught dash is V1 plus V2 by 2 divided by this is V naught plus V1 plus V2 by 2. So this would be 2 V naught into V1 plus V2 divided by 2 V naught plus V1 plus V2. So you can see that A is equal to 2 and B is equal to 2. So A plus B is equal to 4. So the correct answer is 4. Now we move on the next question.